Today we will be seeing in this video applications of distance formula. How we can use this distance formula to verify or justify whether the given vertices are of a particular geometrical figure or no. So let's begin. For example, in this first case, four vertices A, B, C and D are given, and it has been asked to verify whether these are the vertices of a parallelogram or no. Now, as you know, in a parallelogram, the property is that opposite sides are equal. So what we have to do is we have to find out all the four distances, and then we just compare whether two of them, that is the opposite ones, are equal or no. So which are the four distances you will be finding out here? Distance AB, distance BC, distance CD and distance AD. So here you can see I have taken A and B first. Vertice A -1, 6, B 5 and 6. So my A is x1, y1 and B is x2, y2. Then using our distance formula, I have found out the distance AB, which I got it as 6 units. Now similarly, I want to see whether AB and DC are equal or no. So the second distance that I will find out is CD. So I am using C and D. C is forming my x1, y1 and D is forming x2, y2. Now again using the distance formula, you can see I got CD as 6 units. So you can see my two opposite sides have come equal. Now we will find out these two sides. So for the first one, I'm using B and C as x1, y1 and x2, y2. Using the distance formula, you can see I get BC as root 53 units. Now to see whether BC is equal to AD, we will find out distance AD. So I'm again using vertex A and vertex D. So A is my x1, y1 and D is x2, y2. Again using our distance formula, that is x2 minus x1 the whole square plus y2 minus y1 the whole square. Again I am getting root 53 as the distance. So how do we conclude is that distance AB is equal to distance CD. That means segment AB will be equal to segment CD. So we got one pair of opposite side is equal. Similarly, distance BC is equal to distance AD. That means segment BC is equal to segment AD. So we got both the pairs of opposite sides are equal. So our conclusion will be that ABCD is a parallelogram. Now using the same formula, let us go to the second quadrilateral. Here let us say I have got four vertices again and I have been asked to show that they are vertices of a rhombus, right? So now you know the property of rhombus is that all four sides are equal. So using the distance formula, we will try to show that all the four sides are equal. So let's take first AB. So A is x1, y1, B is x2, y2. Again using distance formula, I got AB as root 90 units. Then we go to the second side BC. That is I will be using B and C. B as x1, y1 and C as x2, y2. Substituting it in the distance formula, again I get root 90 units. Now we go to the third side, that is CD. So I'm using the coordinates of C and D as x1, y1 and x2, y2. Substitute in the distance formula, again I get the answer as root 90 units. Now which side is remaining is just AD. So I'll use A and D. Again when I find out using the distance formula, using A as x1, y1, D as x2, y2, again I get the answer as root 90 units. So you can see here all the four answers that I'm getting is root 90 units. That means all the four distances are equal, or in other words, all the four segments are of equal length. That is segment AB is equal to segment BC is equal to segment CD is equal to segment AD. Therefore, quadrilateral ABCD is a rhombus. Now we saw these two, a parallelogram and a rhombus. But now as you know, just as in parallelogram, even rectangle has opposite sides equal. Then what is the difference between proving a parallelogram and a rectangle? Similarly, in a rhombus, all four sides are equal, but all four sides are equal in a square too. Then what is the difference between how to find out whether it's a rhombus or a square? So in the next two examples, we will be talking about it. Now let us say in this third example, I want to show that these four vertices P, Q, R, S are vertices of a rectangle. Now as you all know, rectangle is a special type of parallelogram. In this also, opposite sides are equal. But it has one additional quality which parallelogram does not have, and that is that its diagonals are also equal in length. So if you have to prove that this quadrilateral is a rectangle, not only you will have to prove that opposite sides are equal, but you will also have to prove that the diagonals are equal in length. So here you can see I have found out PQ first using the distance formula. I got root 13. Now the side opposite to PQ is SR. So using S and R, again I found out that the distance is root 13. So I got these two sides are equal. Now let's check these two. So first is QR. Using Q and R, that is x1, y1, x2, y2, I got the distance formula as root 52 units. Opposite of this is PS. So we use P and S, and again using distance formula you can see I have got root 52 units. So you can see opposite sides are equal. So for a parallelogram this much is sufficient to prove that opposite sides are equal. But to prove a rectangle, I have to show that the diagonals are equal in length. So you can see the first diagonal is P and R, PR. So I will be using the coordinates of P and coordinates of R, and again using as x1, y1, x2, y2, we find out distance PR, which I got as root 65 units. Now the second diagonal is SQ or QS. So using the coordinate of Q and coordinate of S, again we substitute in the distance formula to get the answer root 65 units. So you can see both the diagonals are equal in length. This is not the case in a parallelogram. Parallelogram doesn't have two diagonals of equal length. So now how we can write is that distance PQ is equal to distance RS, one pair of opposite side. Then segment QR is equal to segment PS, second pair of opposite sides. Along with that, we have to mention about the diagonal also, that diagonal PR is equal to diagonal QS. Therefore, the quadrilateral PQRS becomes a rectangle. So this is the difference between a parallelogram and a rectangle. For parallelogram, you just have to prove the opposite pairs of sides. But for rectangle, you should show that diagonals are also equal. So now let us see about a square. Now let us say in this example, I have got four coordinates for A, B and C, D, and I have to prove it's a square. Now first step we do is, we also know that for a square also all four sides are equal like a rhombus. So first we find out all the four sides AB, BC, CD and AD using two coordinates at a time. So first I use A and B to get AB. You can see I got root 5. Then I will use B and C to find out BC. Again you can see root 5. Then C and D. So I use C and D again. Substitute in the distance formula. Again I am getting root 5. And last is A and D to get side AD. So again you can see here AD also I got root 5. So you can see all four sides are equal. So now it has become a rhombus. Square is also a special type of a rhombus where the diagonals are equal in length. So I have proved all four sides are equal. That means it's a rhombus. Now to prove it is a square, I have to prove that these two diagonals are also equal in length. So the first diagonal is AC. So I will use the coordinates of A and coordinates of C. Substitute it in the distance formula and you can see I got length of diagonal AC as root 10 units. Now I find out the other diagonal, that is B and D. So for that I use the coordinates of B and coordinates of D. So I use B and D to find out diagonal BD. Again you can see I got it as root 10 units. So how do we conclude here now? That segment AB is equal to BC is equal to CD is equal to AD. That is all four sides are equal and diagonal AC is equal to diagonal BD. That is why this quadrilateral is a square. You can see we are doing different quadrilaterals, different geometrical figures, but the formula remains the same. Formula is just x2 minus x1 the whole square plus y2 minus y1 the whole square. You should take 2 points at a time, give them the value of x1, y1 and x2, y2 and substitute. So this is how you will do it for a square. So for a parallelogram, what we were doing? We were proving the opposite sides equal. And for rectangle, what did we do? Not only the opposite sides, but also the diagonal. For rhombus, we proved all the four sides. But for square, along with the four sides, we did the diagonals also. Let's go to one more example here. You can see I have three vertices, A, B and C. And I have to show that it is an isosceles triangle. Now as the name isosceles suggests, that the two sides should be equal. So what we do in this, we find all the three sides first, AB, BC and AC, using two coordinates at a time. So to find AD, I am using A and B. This is x1, y1, this is x2, y2. And I get my answer as root 13 units. Then next I go to BC. So for that I use B and C, where B becomes x1, y1 and C becomes x2, y2. And you can see I get the answer as root 16, which is nothing but 4 units. Then the third side is AC. So now for this A becomes x1, y1 and C becomes x2, y2. So using these two coordinates in the distance formula, I get the answer root 13 units. Now from all these three sides you can see distance AB is equal to distance AC. Or in other words, segment AB is equal to segment AC. Two sides of a triangle are equal in length. That is why this triangle is an isosceles triangle. Similarly, we can even prove equilateral triangle. In equilateral triangle, we will get all the three sides as equal. We can even prove it as scalene triangle when we get all three as different. Now, last type of a triangle that we have to prove is a right-angled triangle. How we can prove using distance formula whether the triangle is a right-angled triangle or no. So let us see our sixth example. You can see here I have got three vertices P, Q and R, and I have to prove that it is a right-angled triangle. So first step is we find out all the three distances. So first I have found out PQ distance using the P and Q. P as x1, y1 and Q as x2, y2. Substitute it in the distance formula, solve, will get the answer root 16, which is nothing but 4 units. Then we go to QR, using Q as x1, y1, R as x2, y2. Again use distance formula, you will see I got root 9, which is nothing but 3 units. Then the last one, which is PR. So for that I use P and R. So P becomes x1, y1 and R becomes x2, y2. So using that, again in distance formula, I get root 25, which is 5 units. So now you can see I got the three distances or the three sides of the triangle, 3 units, 4 units and 5 units. Now, to prove this is a right angle triangle, I will be using the converse of Pythagoras theorem. You know the Pythagoras theorem, which states that the biggest side square will be equal to the sum of squares of other two sides, the smaller sides. So first what we should do is, out of the three, we should find out which are the two small sides. So as you can see here, 3, 4 and 5. That means 5 is the biggest side and it will form the hypotenuse. 3 and 4 will form the other two sides. And according to the Pythagoras theorem, square of this side plus square of this side should be equal to the square of hypotenuse. So that is what we have to find out. So what we write is one side square plus second side square. So one side is 4, second side is third. So 4 square plus 3 square. 4 square is 16, 3 square is 9. Addition is 25. And now which is the biggest side? 5. So we have to square that also, which is the hypotenuse square. So biggest side square is also 5 square, which is 25. So you can see from these two equations what we get is 4 square plus 3 square is equal to 5 square. Or in other words, hypotenuse square is equal to one side square plus second side square. So it is satisfying the Pythagoras theorem. Therefore, triangle PQR is a right angled triangle. So you can see using the distance formula, we can find out whether the vertices given belong to a particular quadrilateral. We can justify it, prove it also, and show whether it's a right angle triangle, isosceles, scalene, parallelogram, rectangle, rhombus, square, etc. Thank you.